Welcome to your first lesson. Remember to take notes as you would in a normal class, and remember you're not expected to understand everything. Rather, take notes, process the information, and come prepared to class with questions. I will go over each slide during class and be happy to answer any questions that we may have. This section starts off with the definition of a variable. A variable is a symbol which represents a quantity that can vary, thus the word variable. For example, we can define h to be the height in feet of a specific child. Height is a quantity that varies. As time passes, the child's height will increase. So h is a variable. When we say h equals 4, we mean that the child's height is 4 feet. But next year, the child's height h could be 4 feet 6 inches. In 10 years, the child's height could be 5 feet 10 inches. The child's height does not stay the same. It doesn't stay constant. It varies, therefore, it is a variable. Here are some examples. Number 1, let S be a car speed in miles per hour. What is the meaning of S equals 60? Let N be the number of people in millions who work from home at least once a week during the normal business hours. For the year 2013, N equals 20. What does that mean in this situation? Number 3, let T be the number of years since 2010. What is the meaning of T equals 5? Take a second to think of these questions, and we will go over the answers in the next slide. The speed of the car is 60 miles per hour because S is in miles per hour, and it represents speed of the car. In number 2, for the year 2013, N equals 20 represents that 20 million people work from home at least once during the week during normal business hours. Because again, N is a number of people in millions who work from home at least once a week. In this case, since T is a number of years since 2010, if T equals to 5, remember T is a number of years since 2010, so 2010 plus 5 is 2015. T equals 5 represents the year 2015. Here's another definition. A constant is a symbol which represents a specific number, a quantity that does not vary. This is different than a variable because a variable can take on many different values. A constant is a number that cannot vary. That's fixed. For example, my height is 5 feet 11 inches. This is a constant because my height is not going to change anytime soon. As I get older, it'll eventually decrease, but for the next 20 years, my height will stay fixed at 5 feet 11 inches. Same thing with my shoe size. If I let my shoe size S, then my shoe size is 12 inches. This will stay constant because my shoe size is not going to change anytime soon. These are values that are fixed. Here's an example. A rectangle has an area of 12 square inches. Let W be the width and let L be the length, and A be the area. Sketch 3 possible rectangles of area 12 square inches. Which of the symbols W, L, and A are variables? Explain. Which of the symbols W, L, and A are constants? So let's think about what this is saying. We're saying that you have a rectangle that has a fixed area of 12. Okay, now that cannot vary. That is going to be 12. The width is going to be W, and L is going to be the length. The width and the length, they can vary. Here's what I mean by that. One possible way to draw a rectangle with an area 12 is to have the length equal to 12 inches and the width equal to 1 inch. Another way is to let the length be 6 inches and the width be 2 inches, or 4 inches and 3 inches. So the symbols W and L are variables. Notice that here the length is 12 and the width is 1. Here the length is 6 and the width is 2. Here the length is 4 and the width is 3. These vary. However, the area of the rectangle does not. Here the area is 12, here it's 12, and here it's 12. So the symbol A is a constant because in this problem the area does not vary. The area is always 12 square inches. Let's talk about the number line. The number line represents all the numbers, all the real numbers from negative to positive infinity. The numbers increase from left to right. And we refer to the distance between two consecutive integers on the number line as 1 unit. And of course, we have decimals and fractions in between all of these. Numbers are separated, real numbers are separated into rational numbers and irrational numbers. Let's first talk about rational numbers. Rational numbers are numbers that can be written in the form n over d, where n and d are integers and d is non-zero. For example, 3 over 7 is a rational number because it can be written as a fraction, where n, the numerator, and d, the denominator, are both integers. Negative 2/5 is also a rational number. Any integer can be always written as a rational number. For example, 4 can be written as 4 over 1. 7 can be written as 7 over 1. Negative 10 can be written as negative 10 over 1. So any integer is also a rational number. On the other hand, an irrational number cannot be written in the form of n over d, where n and d are integers. So in other words, irrational numbers cannot be written as fractions. Pi is one of the most famous irrational numbers. It's 3.14159, and it keeps the decimals do not repeat and they do not stop. Same thing with square root of 3, same thing with square root of 5. If you wrote these as decimal representations, these decimals will not repeat and they will not stop. These are irrational numbers. A rational number can be written as a decimal number that either terminates or repeats. Okay, this is important. A rational number can be written as a number that terminates, which means it stops, or it repeats. For example, 3/4, it's 0.75, that terminates. 3 over 11 is 0.272727, it repeats. So any fraction can be written as a decimal that terminates or a decimal that repeats. An irrational number can be written as a decimal number that neither terminates nor repeats. For example, pi is 3.14159, and it just keeps going forever without terminating or repeating. The real numbers are all of the numbers represented on the number line. So the real numbers consist of both rational numbers and irrational numbers. So the rational numbers are fractions, decimals that terminate or repeat. Irrational numbers are numbers like pi that can be approximated by 3.14, but we don't have an exact value since they don't repeat and since they don't terminate. The coordinate system, it's made up of the horizontal x-axis and the vertical y-axis. I'm not sure why in this PowerPoint I have it labeled as x and n and q. Sorry about that. We got the horizontal as the x-axis and the vertical as the y-axis. The coordinate system is split up into 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. Notice the quadrants go counterclockwise. And at the center, we have the origin, which is a point 0, 0. When we plot points, we call them ordered pairs. And our ordered pair is always given in the form of x, y. The first number represents the x value, the second number represents the y value. So in this case, x equals 6, which means we will move 6 units to the right. And y equals 3, which means we move 3 units up. The x coordinate tells you how many units to move left and right, and the y coordinate tells us how many units to move up and down. For example, the point 3, 4, we would move 3 units to the right and 4 units up. -5, -3, we would move 5 units to the left and 3 units down. -4, 2, we would move 4 units to the left and 2 units up. 5, -4, we would move 5 units to the right and 4 units down. Now, an inequality contains the symbols less than or equal to, greater than or equal to, with a constant or variable on one side, such as x or y or z, and a number on the other side. So here are some examples of inequalities. X less than -3, -4 less than or equal to 5, 7 greater than 2, x greater than or equal to 6. These are all examples of inequalities. We have a constant or a variable on one side and a constant or a variable on the other side. Now, in this slide, we will determine whether each inequality statement is true or false. 3 less than or equal to 6. Is that a true statement? Yeah, it's true because 3 is less than 6. Now, less than or equal to, this just means that the number on the left can either be less than or equal to the number on the right for it to be a true statement. Part B, -5 greater than -2. So on a number line, this is 0, this is -2, and this is -5. The more negative a number is, the smaller it is. So -5 is actually smaller than -2. It's because it's to the left of -2. So -5 greater than -2, that is a false statement because -5 is actually less than -2. 8 greater than or equal to 8. So greater than or equal to means the number on the left can either be greater than or equal to the number on the right. Now 8 is not greater than 8. However, 8 is equal to 8. So therefore, this is a true statement. Lastly, 9 less than 9. This is a false statement. 9 is not less than itself, so the statement is false. If there was an equal sign, then it would be a true statement. Graphing an inequality. The inequality x greater than -2, this represents all the values that are greater than -2. So any number greater than -2 will be a solution for this inequality. Now we're going to briefly talk about interval notation on this video. However, we will talk more about this during class. In interval notation, we put the smallest number in a solution set on the left and the largest number on the right. So if we think about x greater than -2, this represents all the numbers that are greater than -2. So the smallest value we can take on is -2. However, notice there's no equal sign, which means -2 is not included as a part of our solution set. So when a number is not included, we have a parentheses to represent that. In other words, if our inequality is a greater than or less than, we will use a parentheses. And if it's a greater than or equal to or a less than or equal to, we will use a bracket. But we'll talk about this during class a lot more. So this inequality, the set of all numbers that are greater than -2, is represented by parentheses -2, comma infinity. Now, why is it -2, comma infinity? Because it's just the numbers are getting larger and larger and larger. We want the set of numbers that are greater than -2. When numbers get infinitely large, they approach infinity. To graph the values of x, we shade the part of the number line that lies to the right of -2. So this graph is clearly incorrect. Let's draw an accurate graph. So we have -2, and since the numbers are getting larger, they're going to approach infinity. So it's a set of all numbers that are greater than -2. We have a few more slides, compound inequalities, which we will talk about in class. And once again, we will also talk about a lot more about interval notation in class. So please come prepared with any questions from the slides that I did cover in this video, and we will go over these in class.